Okay, now that we've graphed exponentials, let's see how we can possibly use these in real life. If you look at example number 5, it says the amount of money A that a principal P will be worth after T years at interest rate R compounded annually is given by this equation. So again, the principal amount is the amount that you first start out with. You put a certain amount into a bank to earn interest. The amount of money at the end, we label A. Let's see how much it's going to be worth after a certain number of years, T, if they're giving you a certain interest rate, R, and that interest rate is given to you every single year, annually. So they have this equation to help us figure out how much we're going to earn from our money. So it says here, suppose that $100,000 is invested at 5% interest and it's compounded annually. A, find a function for the amount in the account after T years. So we don't really know how many years we're going to leave the money in this account, but we do know that we're going to put $100,000 in the account. So it looks like that is going to be our P, our principal amount. So I'm going to plug that in for P. I know in the formula I have a 1 plus R. Remember, the R is the interest rate, but normally when they give us the interest rate as a percent, we like to turn that into a decimal so that we can use it in our calculation. So instead of 5%, we're going to plug in 0.05. That's 5% as a decimal. We don't know how many years we're going to leave it in the bank, so we're going to leave that a T. And we don't know what amount we're going to have because it depends on how long we're going to leave it in the account. So I'm going to use function notation and say A of T, or you could just say A equals 100,000 times 1 plus 0.05 T. And so depending on how many years we leave our money in this account, we can calculate how much money we're going to have in the end. If we leave it in the account for 2 years, we can plug in a 2 for T and then calculate. If we leave it in the account for 4 years, we can plug in 4 and calculate how much money we have after 4 years. You can see that it's an exponential because that T is an exponent in my equation because my money is going to grow and grow and grow exponentially as I keep it in the account. Let's do a part B of this problem. Let's actually find out how much money we have in the account at a couple of different times. At T equals 0, so at the very beginning. At T equals 4, so after 4 years. T equals 8, and T equals 10. So at T equals 0, so we first put the money in this account. Well, doesn't it make sense that it should be the original amount of $100,000? But let's officially do it by plugging in the information into our equation. We know that we have $100,000. We know that we have the formula 1 plus 0.05, and we're going to raise it to the 0 power. We're going to leave it in there for nothing. So at the very beginning, well, we know that 1 plus 0.05 is 1.05. Raised to the 0 power, well, anything to the 0 power is really just 1. So then I have 100,000 times 1, which is just $100,000, which should make sense. At the very beginning, we started with $100,000. So let's say I left that money in the account for 4 years. So let's use the formula and plug in a 4 for T this time. 1 plus 0.05 is 1.05. I'm going to use my calculator and do 1.05 to the 4th power. And then I'm going to take that answer and multiply it by 100,000. And I'm not going to round until the very, very, very end. So I'm going to use my calculator the whole way through. At the final answer, I'm going to then round to the nearest hundredths place so I can get right to the nearest cent. So at the end of 4 years of keeping my money in this account, I now have $121,550.63. What if I left it in there for 8 years or even 10 years? If I was patient enough to leave my money in there for 8 years or 10 years, how much money will I have after the end of 8 years or even 10 years? Why don't you plug in an 8 for T, plug in a 10 for T, and see if you can figure out how much money we're going to have in the account after both of those times. After 8 years, I ended up having $147,745.54. So I've just earned over $47,000 by just putting the money in the account and waiting for 8 years before I took it out. That's pretty cool. What about 10 years? If I left the money in there for 10 years and waited before I took it out, I now have $162,889.46. I started with $100,000. Now I have over $162,000. You just made $62,000 for nothing by just putting your money in the account and chilling for 10 years. That's pretty cool. I wish I could Well, first of all, I wish I had $100,000 to put in the bank, but but we can go ahead and use these exponential equations to help us kind of figure out how much money we're going to have potentially in an account, because these formulas end up being exponential formulas.